Welcome to week 5 of Hartlepool College of Further Education's GCSE maths lessons. This week is all about pie charts. Right, so on the next slide, what we'll have is a full grid of questions. You've got about 15 minutes, so when the next slide pops up, press pause, attempt the questions, and then same again for the next slide, which will be all about number for slide 1, algebra for slide 2. Okay, pause now. Right, question 1. Work out 50, take away 4 times, and all in brackets 10, take away 3 squared. Okay, so remember our bid maths, we're doing the brackets first. Within the brackets, I need to do the thing with the index first, that's the 3 squared bit. Now, what I do know is that 3 squared is 9, so on the inside of the bracket, really, it reads 10, take away 9, which is 1. And because of that 4 times on the outside, I'm doing 4 times 1, which is 4. And then 50 take away the 4 is 46. Next question, we've got 3 add 2, and then all in brackets, 5 take away 9 divided by 3. Remember, we have to do the thing in brackets first. Within the bracket, I've got to subtract, and I've got to divide. You do the divide part first. 9 divided by 3 is 3, and really that is then in brackets 5 take away the 3, which is 2. The 2 on the outside of the bracket, means 2 times the 2, which is 4, so really that is 3 add 4, which is 7. Next up, convert 25 over 4 into a mixed number. So we've got 25 over 4, and I know 4 goes into 25 6 times, so whole number 6. I've got 1 left over, and I was dealing in quarters, so something over 4. Next up, multiply and divide. Well, that's 107 times 12. So in my head, I mean, you can do it loads of different ways, but I'm thinking, well, 100 times 12 is 1,200, and 7 times 12 is 84. Add the two together, that's 1,284. And there's other methods. There's grid method, Gaussian method. You might just be able to do that in your head. However you did it, that's the right answer. Next up, we've got 176. And we'll divide that by 8. Well, 8 doesn't go into 1, so 0 times, not use the 1, carries back a column. 8 goes into 17 twice, nearest multiple 16, so we've got 1 left over. 8 into the 16 goes twice. So the answer for that one is 22. Percentages, so whatever we're doing percentages without a calculator, and we are, because it says at the top there, non-calculator, we're looking to find out what is an easy block to work with. In this case, let's say 10%. So 10% will be 30, because remember 10% is divided by 10, so that's £30. And then we want a 5%. Well, 5% will be half of 10%, which is £15. Add the two together, that gets us £45. And then next up, I want 75% of 420. Well, again, we could work in increments of 10, but that might take a while. What we might want to adopt for this one is think, well, 75% is the same as 3/4. So I want 3/4 of 420. Well, that's 420, split that into 4 to find a quarter, so that's 105, and then multiplied by 3 because we want 3 lots of that quarter, so that's £315. And there we're effectively using what we know about conversions between fractions, decimals, and percentages. Next up, the number machine. So start with -2, multiplied by 6 gets me -12. -12, add the 3 gets me -9. Second one, we've got the output -15, and we're working backwards. So instead of adding that 3 on, I'm going to take that 3 away to get me -18. And then I'm going to divide that by the 6. So -18 divided by 6 gets me -3. Next up, some fraction arithmetic. So I don't see an easy multiple, so what I'm going to do is I'm going to say, well, 5 times 3, so multiply the two denominators together, that's going to get me 15. I'm going to cross multiply, so the 3 multiplied by the 4 is going to get me 12, and then the 5 multiplied by the 1 will get me 5, and that was a subtraction. That's 12 take away 5 is 7, that's the top number. Bottom number stays 15, can't simplify that, so that's 7/15. Same method for the next one. The only difference here is it's an add, not a subtract. So 7 times 3 is 21. 3 times the 4, so multiplying these two together, gets me 12. And 7 times the 2 gets me 14. Because this one's an add, I'm adding the top two numbers. 12 and 14 is 26. all over 21. Now I could simplify that if I needed to, because I can say, well, 21 goes into 26 one whole time, remainder 5, and I was working with something over 21. Next up, dividing by thousands. 175 divided by 1,000 means that I have to move the decimal point forwards 3 places. So imagine the decimal point is currently behind the 5. It's going to move 1, 2, 3. Sorry, 1, 2, 3. So in front of the 1. So that's going to be 0.175. Exactly the same with the next one. It's going to move forward 3 spaces. So that's going to be 0.0395. Next up, list the factors of 38. So let's start with 1 and 38, because 1 and the number itself will always be a factor. It's an even number, so 2 must go in. 2 will go in 19 times. 3 doesn't go in, 4 doesn't go in, 5 doesn't go in, 6 doesn't go in, 7 doesn't go in. Pretty sure that's all I've got there for factors, so just the 4. Next up, what is minus 3 all squared? Now the obvious answer to say there is minus 9, but remember what it means is that is minus 3 times minus 3, and remember if we're multiplying 2 negatives together that gets us to positive, so the answer should be positive 9. And then lastly we've got what is the root of 64, so what is the number that multiplies by itself to get me 64? The number is 8, so the square root of 64 is 8. And the algebra stuff, so pause now. And talking through the answers, the first one to simplify, so I have 6xy, and I'm going to take 3xy away. If I have 6 of something and take 3 of that something away, I'm going to be left with 3 of that something, and that something was xy. Next one, multiplying 2 times together, so I've got 3y squared times 2y cubed. Well, I can multiply the two numbers together, that's 3 times 2 gets me 6, and I've got y squared times y cubed. Remember, if you're multiplying things together, if you think back to our lesson on indices, we add the powers. That's going to be y to the power 5. Next up, a couple of two-step equations. So remember that is going forwards, whatever x is, I'm timesing it by 3, adding on 2, and getting a 17. So working backwards, that's 17. Take away 2, leaves me 15. Divide by 3 gets me 5. So for the first one, x must equal 5. For the second one, that's 20 divided by something, add 7 gets me 12. Or working backwards, that's 12, take away the 7, leaves me with 5. So 20 divided by something must get me 5, or 20 divided by the 5 gets me 4. So x must equal 4. Next up, what is the next term in the sequence? Well, this one's a bit of an odd one because it looks like it's going from positive to negative to positive to negative, but the actual value is doubling each time. So that's 3 to 6 to 12 to 24. So the next one must be positive, and it must be 48. Next, what is the value of a plus b, all in brackets, times b minus c, all in brackets? Well, a plus b is 3 take away the 5. So that's 3 add minus 5, or 3 take away 5. So that gets us minus 2. Let's write that above. And then b minus c is going to be minus 5 take away another 2. So that's going to be minus 7. Multiplying those two together, remember 2 negatives multiplied together make a positive, so that's going to be positive 14. Next up, expand and simplify. Okay, this one looks more complicated than it possibly is, and not to get it confused with the lesson we did earlier on expanding double brackets, because there is a plus sign there. So we're going to expand each bracket separately and then just collect any like terms. So that's 5 times x, gets me 5x. And then 5 times the 2 is going to get me 10. 3 times 2x, 6x. And 3 times minus 3, minus 9. Just adding all this together, so 5x add 6x is a total of 11x. So that's that term and that term accounted for. And then 10 take away the 9 gets me positive 1. So there's my like terms collected. Next up, it says the perimeter is 18. Find the value of x. Okay, well, let's just assume that this is a rectangle, and I'm sure in an exam question it would say this is a rectangle. So what we know is that opposite sides group, so that's got to be 2x, that's got to be x, which means the perimeter is 6x, so p equals 6x, and we know that p is also 18, so really we can say, well, we've got px equals 18, so x equals 3. So it's 18 divided by 6 gets me the 3. Next up, some more simplified. So we're going back for laws of indices. We've got a to the 15 divided by a to the power 3, or a cubed. Remember, for division, we are subtracting the powers. So that's a to the power 15, take away 3, gets me a to the power 12. And for the next one, we're multiplying. So we've got c cubed, all in brackets, raised to the power 5. So that's going to be c to the power 3 times 5, gets me c to the power 15. Got a more solve type question. So we've got 6y plus 8 equals 62. So working backwards, that's 62, take away the 8, gets me 54. 54 divided by the 6 gets me 9. So for the first one, y equals 9. And then for the next one, we're on minus 2. Working backwards, we're going to add on that 4, gets me positive 2, multiplied by the 3. 2 times 3 is 6, so y must equal 6. And then lastly, display x is greater than 0 on the number line. Okay, so we've got a number line there. We know it's greater than x, so it's going to be on the right hand side of that 0. So if it's greater than, it's an open dot, meaning that the range can start from there but doesn't include that space. And because we know x is greater than, we just put an arrow in that direction. So x is greater than 0. We'll do a full lesson and go through all the details and the terms needed for inequalities in a later lesson. But that's just to sort of introduce what it is, and I'm sure we remember little bits and bobs from that from school. Today's lesson is all about drawing pie charts. So all we're going to do is talk through a couple of examples, and then I will leave you guys a couple of questions to have a go at, draw your pie charts out, and then compare to some that I'll put up on the screen to show us answers. What you will need in this lesson is going to be a protractor and a compass and a pencil. So if you haven't got those, pause the video, go find them, and then come back. And this is how we do it. So drawing pie charts, here we've got a frequency table, got a few different colors, and we've got the frequencies. And we're going to draw the pie chart from this. Okay, well, first up, we need to know what the angles we need to draw inside a pie chart. So step 1, we know angles around the point, or angles from the point of a circle, would add up to 360 degrees. We need to divide that by the total frequency. So we're going to need to work out the total frequency. So if we add all the frequency column together, that gets a total of 60. And then we'll say 360 degrees divided by 60 equals 6, which means for every one frequency, that's worth 6 degrees. Step 2, multiply the answer to step 1, so 6 degrees, by each of the frequencies to work out the angle for each section. So we need to do 17 times 6, gets us 102. We need to do 22 times 6, gets 132. 7 times 6 would be 42. 4 6 are 24. 10 6 is 60. And then if we add all the angles together, that should get us 360 degrees as a bit of a check. Okay. Always make sure that they add up to 360, because if they don't, chances are we've done something wrong. Right, so if I then take that table with those angles and just shorten it down a bit and make some room to draw out the pie chart, we'll get our circle. Whenever you're drawing a circle, always make sure you put a little marking at the middle so you know where you're starting from. Now, it doesn't especially matter where you start from on a pie chart, but I would usually always start with effectively a north line. So go from the vertical from center. Okay, so what we'll do is we'll put our protractor in place. We'll follow it from the 0 all the way around the outside to about 102 and mark that off. Now once we've marked that off, then using a ruler to draw in a straight line to mark that. So there's our first one. So that's the red section covered. That's 102 degrees. Don't forget to label it. Next up, we'll do the exact same thing for blue. So line up 0 with the last line that we've just drawn in, and then count around 132 degrees. Remember, whenever looking at a protractor, always count around from the 0. So usually on a pie chart, you'll be going clockwise, counting around from 0. So we'll mark that off there. Then we'll draw a straight line through it. We'll remember to label that as blue, and then we're on to green. So again, we want to count round from 0 to 42, mark that off there, straight line through it, label that one as green. and then we've got 2 to go, so we'll do yellow next. So line the protractor up again, count around to 24, mark that off, straight line through it, label that one as yellow. For the last one, you don't really need to draw this one out, but I'll maybe measure it just to make sure that that does add up to the 60 degrees. Now, if you're doing this in an exam, the examiner will usually allow 2 degrees either way as sort of like a tolerance. So if you're within a couple of degrees at the end, I think you're probably doing all right. And that's our first pie chart draw. Well done. Okay, what I'll do is I'm going to leave some table information here. So we've got names of some football players, the amount of goals they score in the season, bonus point if you can guess which team I support, and we'll go from there. So you attempt to draw it, pause the video, I'll put the answer up in a sec, and then just compare, make sure yours looks a bit like mine. Pause now. Okay, so what we should do first of all is work out the angles for each of them. So remember, we would need to work out the total amount of goals that were scored. I think on this one it was 72. And then we'll say, well, that's 360 degrees, divide that by 72, gets me, forgotten, one sec, 360 divided by 72, gets me 5, didn't know that. So we're then multiplying each of these by 5. So we just put those up there. So we'll say 12 times 5 gets me 60, 6 5s are 30, 42 times 5 was 210, and Toby had the same as Rich, 12 times 5 is 60. So those are the angles that you were looking for. Remember, if you don't get everything right, as long as we're getting a lot of the method right, the examiner can still award you some points for this. And for the completed chart, it should look a little bit like that. So just to make that clear, this one should be worth 60 degrees. Just change the color for the next one. This one should be about 30 degrees. Harry was 210 degrees. And purple was Toby, he was 60 degrees. That should look something a bit like that. Right, so if football wasn't your thing, we've got a one here based on trees in a particular kind of forest. So we've got 22 rosewood, 25 maple trees, 24 poplar trees, and 19 mahogany. So remember, step one, we need to work out what is the total frequency. So we'll add all the trees together. That should get us, just give myself a color, 90 trees. So step one was 360 degrees, divide that by 90, and all that's going to be 4. So I know for one frequency, it's going to be worth 4 degrees. So I'm then going to multiply all of these by 4. So we should get this. So rosewood should be worth an angle of 88, maple should be 100, poplar 96, and mahogany 76. And make sure we remember that they're all in degrees. So when you've drawn out yours, it should look a little bit like this one here. So again, we've got for rosewood, this one should be an angle of 88 degrees, maple should be 100 degrees, poplar should be 96 degrees, and mahogany should be 76 degrees or thereabouts. And again, remember, you can be a degree or two out in either direction, as long as it all adds up to 360. The examiner won't be too critical if you're a degree or two out. That is tolerance level. So that's how to work out pie charts. Right, folks, so second grid time. So on the next screen, you'll see a group of questions based around geometry measure. Pause the video, attempt to answer the questions, and then when you press play, I'll talk you through the answers. And then same again for the data and stats grid that follows. So to start with, geometry measure questions. So pause video on now. And write the answer. So the first question says calculate the area, and we have a triangle there. Now, if I was working out the area of the full rectangle, so if there was a full rectangle there, then that would just be 3 times 5. Think of it as the triangle is half of the rectangle, so I need to do 3 times 5 and then half it. Well, no, 3 times 5 is 15. And then half 15, so 15 divided by 2 gets me 7.5. Working in meters, so that was in meter squared. What do we mean if two shapes are congruent? We mean they are exactly the same. So all the side lengths are the same, all the angles are the same. They might be on different level of rotation. There might be a rotation one another, but they are congruent if they are exactly the same. Next up, what order of rotation does this rectangle have? There's no rectangle in there, but let's just say there's a rectangle. So if we were to rotate a rectangle about its midpoint, how many times does the shape land back on top of itself? And for the rectangle, that would be twice, would be 2 times. Next up, reflect the shape in the dotted line. Okay, so just swap back to a color for this. So that point is on the reflection line, so that one goes nowhere. This top point there is 2 squares to the mirror line, so it needs to be reflected 2 squares out. And that bottom point there is 1 squared in, so 1 squared out. That's where the points need to be. I then just line those up. That's my reflection. Next up, how many edges does this shape have? Now remember, that's a 3D representation. It's only 2 dimensions on the page, but represents a 3D object. So think of it as, on the front part of the shape, you've got 1, 2, 3, 4 edges, which means you must have 4 on the back, and you've got 4 connecting front to back. So that's 3 lots of 4, so that's going to be 12 edges. Convert the following. 3.5 litres is how many millilitres? Well, remember, litres to millilitres is times 1,000. So for every 1 litre, you have 1,000 millilitres. So that's going to be 3,500 mil. And 32 centimetres is what millimetres? Remember, in 1 centimetre, there's 10 millimetres. That's times by 10. 32 times 10 is 320. Next, it says, describe and draw a reflex angle. So if we just remember that anything less than 90 would be acute, anything over 90 but less than 180 would be obtuse, anything over than 180 is a reflex angle. So if I had that as my angle, around there, probably about 210-ish sort of degrees, that would be a reflex angle, so it's over 180. Next up, enlarge the shape by factor 2. So currently the base of that triangle is 2 squares across. Enlarge shape, go anywhere we want, needs to be 4 squares across, and the height of it is currently 2 squares, so from there to there is 2, so the height needs to be 4. So if I use that as the midpoint, go there, oops, again, don't have a rule to do this with when recording, but that's the enlarged shape. It's now 4 squares across, and it's now 4 squares high. And lastly, what is the side length of a square that has an area of 25 centimeters? So if we imagine our square, it's got an area of 25. Now remember that a square, all of its sides are the same, and the area of a square is base times height. So we want the number that when multiplied by itself gets me 25, so the side length must be 5. Because 5 times 5, or 5 squared, is 25. And the other way of doing that is to just find the square root, which is what we've done. Square root of 25 is 5, so side length equals 5 centimeters. That's the geometry questions. Next up, data and stats. Pause now. Okay, so first up, we've got what is the range of the data in the stem and leaf diagram. Okay, well, let's have a look at the key down there in the middle. It says key 2 bar 1 equals 21. So we want the biggest value, we want the smallest value. Well, the biggest value would be 3 and the bar and the 9. That represents 39. So the biggest value is 39. We want to take away the smallest value, which is 0 bar 3. So 3. 39 take away 3 is 36. Next up, what is the value shown on the scale? Well, 1, 2, 3, 4, 5 increments on that scale over a range of 20. So 20 divided by 5 is 4. So each little increment is 4, and it's 2 increments up. So that's going to be 8. Next up, it says find the median on the stem and leaf diagram. Okay, so just get rid of the little bits there. Find the median, you find the middle value in an ordered set of information. Now, if we think about this, that's our smallest value and biggest value. And then keep crossing them off in pairs. So next biggest, next smallest, next biggest, next smallest, and so on. And just keep going. And eventually, we're left with one value. So what we have there is the 1 and the 9. So 1 by 9 is 19. So the median value, or the middle value in that ordered set of information, is 19. Next up, find the missing probability. So starting with 1, we're going to take away 0.38, we're going to take away 0.55, and that should leave us, if mental arithmetic serves me right there, 0.07. And that would be the missing probability, because remember, decimal probabilities always add up to 1. Next, what do we mean by qualitative data, and give an example? Well, qualitative data relates to anything that describes a quality. So say if I was to take a survey in the class of everyone's favorite color, that's qualitative data because it's non-numeric. It's something to do with the quality of a thing rather than a number relating to the thing. So qualitative data, anything that describes a quality, in this case colors. If you'd gone the opposite of that and said quantitative data, I could have said everyone, let's do a survey of everyone's heights or shoe size, that kind of thing. That would be quantitative data because that's to do with numbers. So qualitative data, let's say favorite color. What it is collect data that is non-numeric. Next, what is the mode of the data displayed in the stem leaf diagram? Well, let me just clear off the extra bits there. We don't need those for this. The mode, remember, is the most common piece of data. So we're looking for the thing that happens the most often. The only thing that happens more than once are these. Because remember that 1 and these 4s both represent 14s. It's the only time that you have a duplicate entry in the same row. So for that, mode of the data is 14. Next up it says you roll a standard die. Remember, die is just the singular for dice. Dice is the plural. What is the probability that you get a square number? Okay, well, we've got the numbers 1 to 6. So 1, 2, 3, 4, 5, and 6 as outcomes. We want all the square numbers. Well, 1 squared is 1, 2 squared is 4, 3 squared is 9, 2 being 9 there. So there's 2 possible outcomes there. So there's 2 out of a possible 6. That would be the right answer. Usually this will be coupled with a word or a phrase that just basically means and then simplify your answer. We simplify that, divide top and bottom both by 2, gives us 1/3. And then the last question, it says what is the mean of? So we need to add all these numbers together and then we'll divide them by how many there is. So let's have a look. There's 1, 2, 3, 4, 5, 6, 7 numbers. So if we add them all together, that's 49. Divide by 7 because there's 7 of them. So the mean average is 7 because 49 divided by 7 is 7. And that's the data and stats quiz. And that was week 5 for Hartlepool College Further Education in GCSE Maths. This one was all about pie charts. Hopefully you found some use. Again, don't forget, any problems whatsoever or you need further guidance, please do seek advice from your tutor.